I've been asked to find three vectors orthogonal to the vector u, which is minus 4i plus 5j. Well, what I'm thinking is I'm looking for a vector v where u dot v is equal to 0. Well, what I secretly like to think about is that this component is the difference between two x values. This component is the difference between two y values if I'm thinking about 2 points. Right, if I have a point A and a point B, that vector points between them. And then A and B here, right, are really the components of how far I go over and how far I go up. So in this one, I'm actually going to the left and up. But any way I slice it, I could use those to think about the slope of the line that vector lies on. So if I wanted a perpendicular vector, I could just think about swapping A and B and making one of them negative. Because perpendicular lines, right, orthogonal lines have slopes that are opposite reciprocals. Well, and if I think about doing that, that will make the dot product equal to 0. So one of the easiest answers here is to make this a 5 comma positive 4. I swapped the order and I made that one positive. And just look here, I'd have a minus 20 plus a positive 20 equals 0 when I compute the dot product. So there's one of them. I suppose another natural one would be to swap the sign on the 5 instead of the minus 4. So I've swapped them, I've made that one the opposite, and I get a positive 20 minus 20. And now I need a third vector that's also orthogonal to u. Well, the 0 vector is always a lazy choice, right? Because 0 times anything is 0, so this ends up being a 0 plus a 0. But any multiple of either one of these would work too. So 10 comma 8 or minus 10 comma minus 8, multiplying these vectors by 2 or any other constant you want. So the instruction said to find 3, and we found 5 different vectors orthogonal to the given vector. Well, it's more than we were asked to do, but that's good enough.